Hello, I'm Papia. In this problem, we have this function y equals x squared over 2 minus natural log of x. We have to locate any relative extrema and points of inflection of this function. So let's start with relative extrema. Recall that to find relative extrema for this function, we have to use the first derivative. We have to find the critical numbers and then test if those points are minima or maxima. So let's start with computing the first derivative. Okay, so the first term is x squared over 2. So the derivative will be 1/2 times 2x minus second term is natural log of x. So the derivative is 1 over x. So let's simplify. We have x minus 1 over x. Recall how to find critical numbers. It's those points where the derivative is either 0 or undefined. Okay. So where is y prime 0 or undefined? To locate those points, it's better to simplify this expression a little bit more. So what I'm going to do is add them together with a common denominator. Okay, so we have common denominator is x, and then you just cross multiply. In the numerator, you'll have x squared minus 1. And now we have, it's clearly stated what is the numerator and what is the denominator, right? Notice that the numerator you can factor because this is a difference of two squares. So you will get x minus 1 times x plus 1 divided by x. And now it's very clear where y prime is 0 or undefined. It will be 0 when one of these factors in the numerator is 0 and undefined if the denominator is 0. So what are the x values where is 0 or undefined? From the numerator, we have x equals 1, x equals -1, and from denominator, it's when x is equal to 0. So there are three possible x values that can be critical numbers. Question is, are they critical numbers? All three of them? Please be careful. Do not immediately make that conclusion. Check, okay? What you have to check is not only it has to satisfy this property, but also the x value should be in the domain of the function. So let's see, say y equals 0, x equals 0. Is it in the domain? Well, look at your function. If you plug in x equals 0, do you get a value? Look, it's natural log here. Natural log of 0 is not defined. So this x value is not in the domain at all. Okay, what about -1? Same problem. If you plug it in, natural log of -1 is not defined. So -1 is also not in the domain. So can't use that x value either. What about x equals 1? Well, natural log of 1 is defined and the first term is also fine. So yes, this is a possible critical number, and it is. Therefore, we only have one critical number. And that's x equals 1. So we'll have a relative extrema there. We have to check if it's a minima or a maxima. So let's do a quick test. This is your real line. Here is x equals 1. Okay. What you have to do is pick a test point on the left side and the right side and plug it in the expression for the first derivative and see the sign, how the sign is changing. Depending on that, we'll figure out if it's a max or a min. Okay, so let's pick, if you want, let's pick say 0.5. Okay, here is the expression, right? We have three factors, so let's see what happens to y prime. If you plug in 0.5 in the first factor, you get 0.5 minus 1, so it's a negative. Next one, 0.5 plus 1, that's a positive. We don't care about the value, we just care about the sign. And divided by 0.5 is also positive. So y prime will be negative on the left side. Pick something on the right, say pick 2 if you want, that's the test point. Do the same thing. Plug in 2 in this expression for y prime. So 2 minus 1, you'll get positive, 2 plus 1, positive, 2 is positive. So y prime is positive on the right side. So what does that tell you? That tells you if the first derivative is negative, that means the original function is decreasing. And if the first derivative is positive, the original function is increasing. So if it's decreasing and then increasing, what's happening at 1 is a minimum. So the function will have a relative min at x equals 1. Okay, so we're done with first part. Next, we have to figure out if there are any points of inflection. To do that, we have to now take help of the second derivative. So remember what inflection points are. It's a point where the curve of the given function will change its concavity. So it will be from concave up to concave down, or vice versa, from down to up. So we need second derivative to determine that. Okay, so second derivative is derivative of first derivative. Now look, there are so many different forms of first derivative. Choose whichever one you want. I will choose x minus 1 over x because that will be the easiest to take the derivative of. Okay, so what is the derivative? First term is 1 minus derivative of 1 over x, that's x to the power negative 1, use power rule, is negative 1 over x square. So it's 1 plus 1 over x square. I'll do the same thing. I'm going to combine them with a common denominator addition. So common denominator is x square, you cross multiply, so you get x square plus 1 in the numerator. Okay, so to find inflection point, we have to again figure out if there are any point where the second derivative is 0 or undefined. Well, let's see. The numerator is x squared plus 1. Look, that can never be 0, right? So we don't get anything from the numerator. From the denominator, we have x squared. So yes, we can have a possible inflection point at x equals 0 because that's where the second derivative is undefined. So is it an inflection point or not? Please check if the x value is in the domain of the function. First check that. And we already have discussed this before. You know x equals 0 is not even in the domain. The function is not defined. So this x value does not count. And there are no other points. So conclusion is there are no inflection points. Okay, so we have located all the relative extrema and the inflection points. To finish, we have to check our result using a graphing utility. So what you can do is you can graph the function. So use the function x squared divided by 2 minus natural log of x and graph it. Oh, and you see clearly there is a point where you have a minima, and also you notice that this curve is concave up the whole time, and that's why we got no inflection point, because there is no place where the concavity is changing. It's just concave up. Okay, so to make sure that we got the right relative minima, why don't we use trace and plug in x equals 1, and you see that is giving you that minimum value on the curve. So we have found everything correctly. Thank you.